All right, I think we're going to start getting going about now. Let's get into the first parts of the slides.
This is the San Diego Ruby user group.
Oh, yes. San Diego Ruby group. You guys, is anyone here for the first time? All right, so you guys all know what we are. Today, well, first of all, this is Dan Gilkerson. Dan works at version 1. They actually create software to help Agile teams sort of manage their projects. They practice Agile there themselves, a lot of testing. He's been doing Ruby for a while, and Merb for 2 or 3 years now?
Yeah. Azure actually created Merb 0.0.3 for me.
So been around. Tell them a little bit more about what you do, who you are.
Well, I mostly do .NET programming, but Ruby's kind of a hobby project, just like everyone else's now. I work remotely, so I do a lot of remote pairing. We have to, write specs and test a lot to make sure I'm in sync with them and vice versa. So a lot of Agile practices, continuous integrations, things like that. This is Llewellyn Falco. He's actually an Agile coach, and you've been doing Agile for, what?
So since 2002. Right. Now, so we started doing Agile in our own company, and then eventually we started coaching. And it's through that, actually, it's a lot of, me and Dan talk a lot. We talk about testing a lot. We talk about all the practices a lot, but the testing a lot of times gives us a lot of trouble. And then as a coach, I'd go around and we'd be teaching people how to test. And so it was through that this whole thing sort of sparked out of that and it's grown to where it is now.
Actually, and when we code, we only have like an hour or 2 a week to code, so we had to kind of optimize our coding time.
Yeah, so we're sneaking time to code together. So today's talk, Pictures of 1,000 Tests, we're going to be giving it at Agile 2009. So if you don't make it out there, and it's in Chicago in August, you get to see it here. Yay! First of all, we want to sort of start by getting some of the opinion of sort of the crowd. Before we even start with this question, how many people here are currently writing unit tests? Okay, that's about half the crowd. All right, well, that's a start. So how many of you guys think that some sort of regression testing is important to the quality of your software? All right, that's almost everybody. We got 2 shy.
And is your code run at least once before it goes into production? Raise your hands.
That is everyone. Even the people who don't think regression was important, at least run their code once.
Yeah.
That's good.
We've actually been in a crowd where some hands went down.
And then our last and final question is your code well covered by automated unit tests? That's impressive. We got 5 people there. All right. Let's write these up.
All right.
So regression tests. Just judging from the side of the crowd, we got about, say, 15.
Okay.
And then 16 for automated, or for running.
Yep. And
about 5. Okay, so first of all, congratulations, Ruby people.
Yes.
This is better than any other language group we've ever talked to, where the next number is usually like 1. But we want to talk about why, even though this is much, much better, there's still a pretty sharp decline here between people who think that it's important to do regression, who at least do it once, but then don't make that jump to getting good automated coverage. And so our question sort of is why? And don't be bashful. Yeah?
Well, once I know what the code's going to do, I'll be very happy to write tests.
So you don't know what it's going to do ahead of time.
Right, I'm just working with the client, prototyping.
Yeah. We see that a lot. Anything else? It takes a lot of time to write tests. Yeah?
I jumped into projects where there's already a lot of code.
Like the burden of legacy.
A lot of legacy.
Yes.
Do you not necessarily want to test all your code? Maybe there's some private things that you don't need to pass through. You don't have to change a lot of things.
So you're saying that basically like you have to maintain the tests.
Well, we always have to maintain tests, right? But there's always a balance between.
No, I think that's valid. You have to maintain the tests. And so sometimes it's just not worth the maintenance.
This is real simple, and I mean, I'm not a professional programmer, but when I'm programming the site, I just click through it and make sure everything works. So,
Okay? So if it's simple and you click through, you don't feel the need for it. Is that what you're expressing?
plus I don't know how to do it.
Ah,
So let's add both of those as separate items. Don't know how to do it. Seems simple enough without it.
yeah, okay.
Okay? Anything else? All right.
Wow.
That's a good number of reasons not to test. And a lot of these I think are really valid. Right? So let's go in and take a little look at what goes on with testing here.
What are we going to do today?
Exactly.
Well, with one line, we will give you an automated regression test, which, yes, does sound kind of like a marketing phrase, but we will show that.
That's our goal for the next 40 minutes.
Yep.
It won't.
No.
Now, we should end early. You'll be happy.
This group will get it.
So first of all, we want to address this right up front before we even get into it. This is a familiar pattern for a lot of people: arrange, act, assert.
And in Cucumber, right, that's given, when, then.
Yeah. You'll see this a lot of times. Because we're going to operate at a slightly higher level, we're not going to use this paradigm. Instead, we're just going to use the paradigm do and verify. And you'll find with any kind of test, whether it's automated or not, this is really the two things that occur. You're going to do something, and then you're going to check that it actually happened the way you wanted it to occur. So just so we have everyone on the same page, these are the two parts that we're really going to look at: do and verify. Everybody okay with that?
All right.
10 yes, but okay. So first, let's get into the code. Let's do a small example of doing some testing,
All right.
and take a look at what really is involved in writing just a simple unit test.
Sorry.
So we're here in TextMate. Ooh, can you guys see that? Can you put that into Lucidia?
Shortcuts, everyone.
Gesundheit. Can you read that? Okay, you can definitely read that. All right. So we're going to start here. We have a TV show. And the first thing that we want to test is that, the TV show has a start time and it has an end time. And we want to sort of test that it's calculating the length correctly. So pretty straightforward. First thing we're going to need is to create a TV show.
Okay.
And we're going to have to pass it a start time and an end time. When should it start? Anybody? All right. We didn't use half numbers, so we'll say 6. And when should it end?
It's a very simple system.
7. Okay, so we should have a 1-hour show here, right? So that's pretty simple. Let's just, hold on to that. And let's just put it out to the line,
Okay.
right? Show dot length. No. Show dot length.
Sorry. Yeah, got the time. That's great. Everybody does. All right.
Okay, so what do we expect to see here? 1 hour? Okay. Good, and we see 1. Can anyone see that? So that's a pretty easy test, right? It's not automated, but we ran our code. We saw that it works. You mentioned earlier that this is a simple thing, so we don't have to worry about it too much. But it would be nice to make sure that it will always work. So let's just put that under a test.
So we got 1, right?
So we're using Rspec here as our testing framework. Yep. All right. And now that green actually means something. If we were to go back and say equals 2, you'll see that this fails. Okay? So that's pretty simple. Everybody sort of familiar to this paradigm?
Yep.
Right? And you can see, go back. There's not too much difference really here in either effort or anything between printing it out and writing the test. Right? So it's really simple to write these kind of tests. TV show, though, has some more stuff. Let's grab something from our database and look at the summary.
All right. So another show?
No, load one.
All right. Was that from the cable company?
Yeah.
What's it called?
Flight of the Conchords.
All right. Hey, take that whole thing out. All right.
All right, and let's hold on to that TV show. And now let's take a look, and we'll just spit it out to the console, what the summary looks like.
Yeah?
Yep.
All right.
Good. Zoom in on that so they can actually sort of see what we're dealing with here. There you go. Maybe not that much.
Sorry. Okay.
All right, so here we have just sort of a good summary of what this show is. It includes the times into there and tells you the title and just sort of puts it all nice and together, right? So it's easy enough to do. We can scan it. We can see that we like it.
Yep.
Let's go back and let's start putting this under test. So we can get the same protection for this summary method as we're going to get for the length. All right, so title,
What?
Flight of the Conchords, I believe. Flight, not file.
I can't spell.
And I think there was a return statement.
Let's look. Was
Let's
there?
look at that again, yeah. Yes, so a double return statement.
Right.
Okay. But I think there was a space in there too.
Where? Before it?
Before there, yeah.
All right. This is getting
And then,
painful.
yeah. Okay, this kind of sucks, right?
Can I just cut and paste it?
At this point, you would probably stop testing this because it's simple, and that sucks. Right. Okay, so we're going to show you a different way to think about testing to handle this, which is the simplest thing we could think of. We're still dealing with just a primitive data type. It just happens to be a little long, and even just being a little bit long, it kind of sucks to test. All right, so we're going to pause this for a little bit and do some approval theater.
Yes. All right. This is the interactive part. It's like SeaWorld. Everybody is going to be affected.
There. So we have a pedestal here. It's actually a chair, but you make do with what you got. And we're going to run a little scenario. And we talked about the do and the verify. And we're going to be the doers, right? We're going to be the part of the test that produces something. And you guys are going to be the verifiers. Okay? I would suggest just setting your laptop down for a couple seconds. Okay, so the rules are pretty simple. When we produce something, if it matches what's on the pedestal, you're going to tell us pass. And if it doesn't, you're going to tell us fail. Everybody sort of understand where we're going here? All right, so we'll run the test the first time. Pass or fail? Fail. Why is it failing? Nothing on the pedestal here. So this is the case all the time when we run our test, right? Yep. The pedestal always starts empty. I like that ball. It is a pretty good ball. You guys like the ball? See some nodding. Okay. We're going to put it on the pedestal. Let's run the test again. Pass or fail? Pass. Beautiful. We produced the same thing that was on the pedestal. Test passes. But that's not why we have tests, right? We have tests because we want to find out what happens when things don't go right. Fail. The ball is not the same. All right. So, okay, if Dan's going to go in there and break the code, we're going to have to go back in, fix it up. Pass. All right. So we're able to detect that we're back to where we want it to be.
Now who in here has continuous integration?
Coolio? All right. So because we have continuous integration, and how many people here work on teams of more than one person? Most of the people. All right. So because of that, we're going to have to run these tests not just on our machine, but on the continuous integration, other developer machines. Pass or fail? Pass or fail? All right. We didn't hear anything from you. All right. So a little bit more time is going to go on. We're going to run the test in the future here. Way in the back. Pass or fail? Yes. This ball is definitely not matching this ball here.
But this is a better ball, I think.
This is a better ball. This made it all the way to the guy in the back. Let's knock this off the pedestal.
All right.
Put that one back on the pedestal. Run the test again. You know how programmers are. They always go back and revert your code. Pass or fail?
Fail.
Even though it used to be on the pedestal, it doesn't matter. It only matters what's currently on the pedestal. Right. And then one more code change. Fail. All right. So that's the theory of approval testing. If what you produced matched what you produced the last time you put it on a pedestal, your test is going to pass. If what you produced does not match, for any reason, it's going to fail. Everybody got the idea? Let's take a look at the cheapest way we can do this. Let's go back to that problem we were just having. All right. So here we have the summary. Let's first create a variable there called pedestal.
Yeah. How do you spell that?
Let's call it approved.
Approved.
All right. And it's going to be empty because the pedestal, if you remember, the first time is always empty. And now we're going to say this should equal approved.
Okay.
All right, so let's run this test.
Does not. Oops, sorry, Jim.
All right. So we expected nothing, but we got this thing. So let's read it. Do we like it?
Yep.
Copy it. And let's run it again.
So close. So close.
Oh, you added the using at the end of the summary line.
Oh.
Or no, you added the return. Sorry.
Which return?
You're missing the new line.
Oh, yeah. I missed new lines, though, man.
Oh, you're right. You actually want to take the whole thing inside of the string.
This guy's what I want now, right?
Yeah. Copied the wrong thing. Sorry about that. All right, run that. And we're passing. Okay, so very simple. And instead of trying to figure it all out beforehand, we're just going to recognize that we got it, move it in there. So let's go back to the code, just take a quick look at how this pattern works.
This guy right here.
All right, so we're going to create what we expect, and then we're going to check that they're equal. Does that make sense? You might have noticed that we're a little bit conning at this point, because we promised you one line of code to lock your test down. And how many lines of code is that?
More than one.
It's 2 lines of code. That's almost double what we promised. So what we're going to show you is just an alternative way of writing that exact same thing. So here, we're going to delete those 2 lines. And we're going to do the exact same thing, but we're going to use an approval for it. So I'm going to say approvals.approve, show.summary.
All right, what do we get with this?
Now, when you run this the first time, the pedestal is empty. So it's going to pop up, and in this case, we're just popping it up in a diff viewer. Let you see what came out and what was on the pedestal before, which in this case was nothing. If we like it, we're just going to move it over.
Okay.
Save it. And let's rerun the test. And now we're passing. Does that make sense? The first time we run it, we produce our artifact. When we recognize that we like it, we put it onto the pedestal. And after that, as long as it matches, we're OK.
Yep.
Sorry, say again?
Go ahead.
I have no idea what you did that approved that you got the right result and where to save.
OK.
All right.
This is both fair. So first of all, let's take a look at where it's saved. So let's go into specs.
All right.
So notice here that our test is,
You see that?
wait, go back to the test for a second. That we're describing TV shows, and we're saying that it should display the summary. So in the same place where that file resides, we're going to create another file which takes the 2 things, tacks them together. TV shows should display summary, if that was large enough to, there you go. And then .approved. That's,
Did you create that beforehand, or was it created in the course of running the test?
that was created, here, delete that file.
Okay. So that, yeah, that was created with, oh, okay.
All right, let's run it again. So now there's nothing.
Right.
When we run it the first time, we create what we result, which is going to be the exact same string .received.
Yep.
Running the test causes the diff view to come up.
Yes.
Right. So you can see here, we've got an approved that's empty now and a received.
And then
What we did to
when we move that over to the left,
the right, the left, the right, depends which way.
the
you're
right,
looking.
yes, the right, and save that file, that's how we moved it to create that actual artifact. All right. Pretty simple? Everyone has the basic idea of how this goes. All right, seeing some nodding. Let's take it a little bit further.
Well, let's see what happens, because the wonderful speller that I am. Did I spell all these things right?
Well, let's just look at the artifact, actually.
All right.
You just go straight into there. Okay, and actually we can find out that we didn't. So let's use our tool here to fix those 2 things. Now here we're just fixing what we expect to be, this is like our bug report right here. So when we run it, we should now have a failing test. And you can see that it is failing. And because we're able to harness the power of diff tools, you can see exactly where we're getting things, and we got an extra L out here that we shouldn't have. So let's go into our code. Let's change that.
All right. What was it? Deal endeavors. Right?
Yep. And then an L on actually. So we change our code, rerun this code, or rerun the specs, and we're back to passing. And this is just a nicety of the fact that diff tools are a much better way of showing us where individual changes are when you have a lot of stuff. So let's jump back to our slides.
All right.
All right. So complications. We talked here about the balls. We put them on the pedestal. If you're going to test the old way, you're going to look at the properties of this ball. What properties of this ball would you test to make sure that we have the ball?
What would you assert on?
Shape. Would that tell you that you got this ball? It'd be 1 step.
Right.
But would it guarantee that you have this ball? So what else would you have to test? Color. Would that tell you that you got the ball? What else would you have to test? Size. Would that tell you that you got the ball? What else would you test? Texture. Hardness. Anything else? Mass would be good. Anything else? Bounciness. Anything else? All right, that's a fair amount. This is one of the things that we find when you start teaching people how to test. There's a lot of things that you can test. Now, nobody here would actually test all those things because it's really annoying, it takes forever. Like as soon as you start going down that path, you stop testing. And so one of the things that we find, one of the skills that people learn with testing is they figure out what is the key element that you're going to test. Right? And that, of course, becomes easier if you sort of manipulate the circumstances of what you produce to sort of highlight that element. Right? So we have all these things we want to test. What do we take a look at? And there's a really good scenario that comes up with this a lot.
Lists?
Yeah. You use lists quite a lot, right?
Sometimes.
Yeah.
Yeah.
I would say that every week I'm programming a list. You guys ever make an array or a list? All right. So let's take a look at how we're going to test against a list. All right. So the idea here is that, again, we have these TV shows. We have a cable company. And what we want to be able to do is sort of say what shows are on between a certain range of time. Right? So first, let's just see what we have. Right? So let's get those TV shows.
Okay.
All right, and let's hold on to those. Now, in the end, we're going to want to filter these. But right now, we don't know how to do that. So let's just say filtered equals shows. So we just get everything.
Okay.
All right, and then let's approve that.
Okay.
All right, let's run that. Sorry. Let's go back.
So this is a list, right?
Yes.
And
So instead of saying approve, we're going to say approve list.
Yep. And with the list, we just kind of want to give it a label, right?
So TV.
All right.
All right.
That's
Can
better.
you zoom in on there again?
Sure.
All right. So here we have a list of 9 shows. All right. We have the Flight of the Concorde, CSI. Let's filter. Do you have a time in mind?
I don't know. Let's ask somebody.
Give us a start and an end time. 5 to 6. All right. So we're going to filter all the shows between 5 and 6.
Want to set them? By
Yep.
hand?
So, okay. So depending on your merge tool, sometimes you can move individual blocks. In this particular merge tool, we can't. So we're just going to move everything over and go straight to our editor to take a look at it.
Oops. Okay.
All right. So first of all, we got this 4 to 5. Is that going to make the cut? No. So let's kill that. CSI, is that going to make the cut? No. Daily Show, is that going to make the cut? No Friends.
What's the
Yes,
time?
no? No. Okay. Boston Legal, 5 to 7. Yes. All right. So no. I mean, this is one of the reasons that we do test in the first place, to actually refine what it is that we're speccing. You said between 5 and 6. So the question now comes up: does that mean that the show is on between 5 or 6, or does it mean that the entirety of it starts in between? You are the one who came up with the time. What do you want? The whole thing. Okay. So in that case, does it make the cut? Doesn't. Boston Legal? That's the same. Is that the one we just did?
Yeah.
Okay. Kill it. The Office? Star Trek? The Next Generation? And another show. So this is sort of what we want. Let's save that.
Okay.
And now let's go back to our thing and let's do the code to implement this. So shows dot, or cable, or TV shows, yeah, lowercase v.
Oh, yeah. Okay. What do you got?
TV show, sorry.
Yep.
Dot between. I'm going to pass in shows and 5 to 6.
Yeah.
All right, and let's run this test again. All right. So you can see that it didn't quite pass. We got everything we expected, we just didn't label the indexes right. But that's what we want, right? Everyone in agreement? So let's move that file over.
Okay.
And save it. Run the test again.
And we're good. Side effect of the Diff Tool.
Oh. Yeah.
There's a new line.
There's a new line. Fun. Okay, so we're going to do a manual move here. Actually, so in here, let's just go and put a reporter. So approval test.reporter.
Okay.
Ooh, it will report. Oh, yeah, it should. Okay, approval test.reporter, the TextMate.
We have a TextMate reporter.
Yeah, dot instance, yeah.
Nope.
Nope. Yeah, try that.
Wrong one. Nope.
Nope. Remove the earlier reporter that we put in. So kill line 31, but we also put in a diff reporter above.
I just took it out.
You took it out? Okay.
There you go.
All right, so now we're going to run in TextMate just because we have the inconvenience of a new line causing us trouble with our diff tool. So now we get what came out of here that we want, and we can just click on the approve above to move the file over like we did before. And that does a direct copy, so it works really nicely, especially with images and stuff like that.
Right. Yeah. It doesn't rerun the test, unfortunately.
So now we can run and we're passing. So everyone follow where we did there? I see some shaking, some blank stares. Go take a look at the thing that got approved. All right. First of all, I want to point out, you didn't have to think about how to confine a list that came out here. We did a list that was 5 to 6. Let's go and really quickly.
Where?
In the test.
All right. Oops. Wrong one.
Let's change the spec. So instead of testing between 5 and 6, let's test something much bigger. Let's test like 2 to 8.
Okay.
And, all right. So here we're generating a different thing of results. We can quickly scan and see that they all fall cleanly between 2 to 8. And we can approve that too. Just approve that and show us passing. So unlike the ball, where we had to consider quite a lot of different attributes, right? And if you were going to spec test the list, you would consider these exact things. Are you going to test the length of the list? Are you going to test an individual element of the list? Are you going to check the order of the list? Are you going to test that it only contains what you passed in? Here, we just get to see the thing. We get to see what it produces and say, hey, that's actually what I expected. Not good? All right, let's continue on just a little more.
All right.
All right. So in the strings, they were very simple, right? Because you could just read a string. And the arrays are really simple because they lend themselves to that sort of display. HTML, it turns out to be very nice and simple too. HTML, a lot of times you're actually paying a designer to visualize the state that your code is going to exit in. Right? So let's take a quick look at what it's like to do some testing of some HTML using the same theory. Right, and here we're just widening our scope to different things that we want to test. You don't have to widen your scope, and it's not always advisable to widen your scope. We want to let you see sort of, you can now choose the scope based on the behavior you're trying to describe.
All right, so we have a MERB app here. Pretty simple.
Make that bigger like we did before.
Oh, right. Wow. Have a service, just returning some HTML.
All right, so let's test that.
All right.
So here we are in our spec. So first of all, we have to do the do part, right? We have the do and we have the verify. But the do is quite simple. We're going to call the web page. And therefore, the verify becomes almost equally simple.
Yep.
We're going to approve, and HTML approve here, the body that comes out of this call. Let's run that.
All right.
All right. So here we have in the window, you can actually see the way that the page renders. If you like the way the page renders, let's make that a passing test.
Can approve it.
So we're going to go up there, click the approve, run it again, and we have a passing test. The very nice thing about this, well, there's a couple nice things about this. One is trying to figure out which particular feature to test when you're talking about a page is much, much worse than the ball, right? Actually, so here we have another nice thing. Open up our test request.
Which one?
The specs.
Right.
Yeah. So here we have the artifact. Let's take a look at that. Possibly.
Oh, it's trying to hit herbivore.
Oh.
So we actually have a base tag in here just because.
Because we're not connected to the internet?
Right.
Ah, shoot. Is that because your pocket thing is off?
Yep.
All right. Let's go back and run it through TechNet again then.
Well, wait. How did that work then?
How did that work, actually?
That makes no sense then.
Just kill the file.
Yeah.
It must be caching the internet call then. Strange. So we're pulling our style sheet from online.
There we go.
There we go. All right. So pull down. Notice there's a lot of things here. And how they all work, how they all play together, is important to what your customer actually wants. Right? This gives you two things. A, it simplifies what you have to do to test it. Right? Instead of trying to pick out the individual pieces and test them, you can look at the whole thing.
Or even just take blocks, right?
Yeah.
So instead of building regex expressions to take out chunks, you can just get that chunk and then.
And render that. And we do that a lot, because a lot of times pages are sort of subdivided in sort of smaller divs that are actually calculating that piece. And there's no need to look at the whole thing. You can just look at the one piece that you're actually writing. And then the second thing is that it actually makes sense. Like what you see, if you're looking at your test later, right? If you come into someone else's test and you're saying, when I do this, what do I get back? It's a lot simpler to put that together when you can see the big picture. And then the third thing is that you have those artifacts. So let's go in there and just change something.
Right.
And then let's run this again. Oh, did we approve the last artifact? Did we get our test running?
Oh, we didn't, did I?
You didn't approve.
No. Yay.
So approve it. And then go back and unchange that.
Yep. I don't have the diff reporter on.
All right. We can throw it in.
All right.
All right. And then, all right, so this fails. But let's bring, actually, just go into your file system.
Okay.
So we have now what we got and what we did. Let's take those two and diff them.
You have a diff here.
I think it was called something diff.
Lovely. I don't know. Don't remember what it's called.
All right. Put in the diff reporter and do it that way. So approval dot reporter. Reporter.
That's not what I want.
Diff reporter dot instance.
Okay.
Run that again.
What is this called? Nope, that wasn't him.
Did that not work? No, it didn't, because it didn't pull it out.
Didn't like that guy.
Operation not supported. Applications different. That's the right thing.
Doesn't like HTML.
That would happen on stage. All right.
Wait, what's this guy called?
VI different.
Merge.
Is anyone here good enough with VI to tell me what that command is? To diff two files on the command line?
There we go.
Type what he just said.
What did he just say?
Go into the, so go to the Rspec file.
You've got Apple's developer tool with the Diff Tool in there.
Is there?
Yeah?
Oh, good one.
What's it called? It's okay. Okay, what did he say?
No, so what was the diff command? The two file names?
Mr. Receive, no?
Yeah.
Sexy.
That's
not colored.
that's not colored or nice.
File merge. What's that?
Yes.
Yeah.
You can, but the better the tool is, the easier it is for you as a developer to really see what the difference is. But you're right. You can see the individual lines. It becomes a little bit harder to merge them, a little bit harder to reconstruct both sides in your head.
Oh, that's not.
There we go. That is how something should be reported to you when it goes wrong, right? Even though there's a lot here, right, you're not overwhelmed by the amount of information. You can get right to the line that goes, and not even the line, but exactly to where the piece is that is changed. That's a very powerful thing when you're working on code. And diff tools, though we're not responsible for diff tools, are totally focused on saying, I have a lot of something, show me the individual trees that have changed. Right? You can do it with text files. You can do them with images. Diff tools are great in this respect. So it's really powerful to let you see something has changed. All right, so that gave us the ability to see the HTML. Let's take a look at another situation here.
All right. That one. Oh, XML.
XML. That's another thing that we use quite a bit. I'm assuming it's the same thing here. Everyone here use XML a fair amount. XML is another place where testing it becomes really annoying because you get these big blocks of XML, and it becomes an issue of sort of how are you regexing it, or how are you finding the individual piece that you actually want to test. So here we have another one. We have an XML feed. We're going to do the exact same thing as we did before. We're going to do the do, which just produces the response, and then the approve.
And I have a different order on.
And first of all, notice something. The first thing is that this is nicely formatted, right? But when you pass XML out, it's usually not. Before you do this, just print out that exact same thing that we're doing.
Okay. So this guy right here.
Yeah. All right.
Yeah.
It strips out all the stuff. Throw a pre around that.
Oh. Doesn't it? That's nice, isn't it? Sorry. Yeah.
And a pre after it, yeah.
Close it
Try
up.
that. It still strips it out.
Yeah, this is TextMate being smart.
Okay, well, it brings us to yet another issue. That even viewing it in TextMate is annoyingly hard. But if you if it was not stripped out, it's all on one line as a flat piece of XML, which is normally how you send a piece of XML across the wire. It's annoyingly hard to read. It's annoyingly hard to diff. So here we get another aspect of the tools. The tools have a nice aspect of they are putting effort into visualizing your response in a way that's easy for you to consume. So run that again. Take a look at the XML. And here we're going to scroll up and down. Actually, we can see this even nicer. Go to our file system again because we have the artifacts that are produced. Let's pull that out.
Whoops, which guy? This.
Do we have a good XML viewer?
Well, these are text now, but
Just rename it to an XML and open it.
this guy?
Yeah.
Well, he's the one that's saved, right?
No. Boom.
Oh, lovely. Yeah, see, that's what I get for installing X tools on your
Here.
your laptop. Hey, we do this. Yeah, that's great. Thanks. Yeah.
Enable recommended.
Which guy?
You have enable recommended.
Oh.
Recommended. Yeah.
Yeah.
Ah.
We didn't approve it yet. That's why I'm opening the wrong one.
Ah.
Smart. Doesn't remember.
There we go. Okay, that's nice XML to read. And the only reason we can do this is because rather than just having a test that ran and threw something on the screen, we actually have artifacts that we can open, right? Which means if it's XML, we can look at what is produced in a browser that shows us XML. If it's HTML, we can look at it in a browser that shows us that. If we're pulling back a database query, we can spit it out as a CVS file and look at it in Excel or look at it in numbers. If it's a picture or an image, if you're taking a screen capture to display what you have, you can pull it up in Photoshop and actually see what's going on, change it.
And the
Right.
key benefit is if you're working with the customer, they can understand this. It's more than asserts.
And they can create it. We've done work with XML in particular, right, where I have customers who, if I was to show them an angle bracket, the conversation would essentially be over. But you can pull a visual XML editor, and they can understand a tree. And they can go through, and they can say, I want something that looks like that. And they can understand that, and they can model it in a tree. And once you do that, your job becomes pretty simple, right? Because you just set that to your approval file, and it will tell you line by line if you're producing what your customer is actually expecting. If you're creating an HTML page, they can actually take it into a WYSIWYG editor and say, this doesn't look right over here, and this doesn't look right over there, and you can get back sort of, this is what I had, and this is what they actually wanted. And it doesn't matter that what they wanted is horrific, right? Because a WYSIWYG editor is going to completely screw up everything you actually want in your code. Because as soon as you produce it so that it looks the same, you can just move it over and approve what actually is going to be produced. For that matter, when we do, oh, we don't do it with Ruby, but if we do like Windows Forms, I can just bring up a Paint program and have them hand draw a sketch of what they want. And that's good enough to ship to a developer and say, make that work, and they can look at the hand form and what is actually being screen captured from their application. And when it matches, they just move it over, and their test is now passing. And we can actually see through version control, are they actually fulfilling the requirements that are coming across? Which brings us, did we talk in here about the 4 parts of the test?
Yep, it's coming up.
Okay. So we want to talk a little bit about why test. Because when you started testing, why did you want to test?
Well, for me, I just wanted to make sure my code was working correctly.
Yeah. And I think most people, when they think about testing, that's what it means, right?
Yeah.
Which is really, it's regression down here, right?
Yep.
This is the idea that your code works. But it turns out, once you start testing and using TDD or BDD, you get a lot of other benefits that occur. And the first is specifications.
Yep.
There's this idea that you need to know sort of what it is that you're talking about. Everybody here will acknowledge that it's nicer to build code when you have good requirements. Specifications are very good requirements. They're requirements that you can execute against, right? And so the first thing that we really gain is that sort of, as soon as you go in to write a piece of code, if you write your test first,
Yep.
you know exactly what should be there, what should be called.
And if you can, now you can specify a more abstract concept, a detailed concept. You don't have to use tables or.
And really, specifications, if you look at sort of the pockets that are emerging in testing, behavior-driven development is really that focus on specifications. You'll see that, especially in Cucumber, we're looking at getting specifications that the user can read, right? And Cucumber does a lot to move us into that direction. It still runs into this part that after you spec the do part, the verify becomes very complex because you're going and you're pinpointing little things to look at.
Then.
Yes. Feedback. Okay, so I picked up a friend and we were headed out to Vegas. I picked him up in Los Angeles, and we went out, and I hadn't seen him in a while, right? So we're chatting, we're having a good time. And we totally missed the 15 going north. And we realized this when we got to Palm Springs. Right? We're like, we're not supposed to see Palm Springs.
Too far.
Right? And so we turned around, we came back, and that mistake cost us about 2 hours, a fair amount of fighting. And, had I had a GPS, I probably still would have missed that turn because we're not actually paying attention to where we're supposed to be going. But as soon as I missed it, I would have heard that recalculating route. And I would have turned around at the next exit. And that same mistake, instead of costing me 2 hours, would have cost me 5 minutes. So I would have paid a lot less. That's the value of feedback, right? You still make the same mistakes that you would have made before, but you're paying a lot less for them.
Because you're aware of them.
Yeah, it's just simple awareness. But a way that most developers go is they program. And instead of getting that instantaneous feedback back from a test, they'll ship it over to a quality control person who will give it, they'll ship it over the wall. It'll take about a week. A report will come back. The difference between getting feedback from a test in 30 seconds and getting feedback a week later is me realizing that I didn't make it to Vegas because I've seen the Atlantic Ocean. Feedback makes you program a lot faster. It gives you a lot more bang for your buck.
Yep.
Regression we already talked about. Regression is what most people think of when they think of testing. And then there's this last part, granularity.
That's the nice fine details, right? When things fail, pinpointing where.
I'm sure you've all had bug reports, something to the kin of, it doesn't work. That's a good bug report to know whether or not your code works, right? Specifically, it tells you that it doesn't. But it doesn't help you at all to fix the problem. Good granularity does. A bug report that says, when I run customer 15 on the July 17th report, I should see an expense of $45, and instead I see $35. That's a good bug report. That's something you can fix. Right? And the reason is the granularity.
Yep.
Right?
Like
and
the
that's,
HTML that we looked at, right?
Yes, exactly. When you can pull that up into a Diff Tool, and you can see exactly what's going wrong, that's really powerful. The other way you can achieve granularity, of course, is to write much smaller tests to test smaller pieces, which is how TDD approaches this problem. When something goes wrong, they have a very focused, this test is failing, so it's in this area of my code. Yeah. However you achieve any of these things, they're all very valuable aspects of testing.
Yeah.
I mean, want to point that out.
I actually have an example with granularity that I've been doing. How many people out there use mock frameworks? So one of the things that I've done is test the interactions that my controllers do against models or my views. And instead of actually specifying all the different calls I expect my controller to be making, I just record the calls, and then I approve that list. And then if it ever changes, I can see what new calls were made. So.
Yeah, it's a nicer way to set up a mock.
So right now, I'm actually working on a library called Checkpoint. So that's actually using aspects to disable the real method calls and allow you to record every hit.
Yeah. Once you get approvals under your belt,
Yep. Then you try.
the next step is looking at how do you take the path it took and chop it up. And that's checkpoints. But that's a secondary talk.
Yep. That's another library.
Okay, let's go to slide 5.
All right.
All right, so we talked about this in the very beginning. Don't know what it's going to do. Who said that? Over there. Okay. Do you see now how approvals doesn't force you to know exactly what it's going to do? Okay, fair enough.
Yeah.
Notice that you don't have to create the approved file ahead of time. All right, so you can go set it up to run the piece of code that you're about to write. Write it, and look at what it produces.
You have to be able to recognize when it's right.
You have to be able to recognize, yes. And that's true. And hopefully by the time you've programmed whatever piece of code, you've gotten yourself into a point where you can recognize that it produced what you intended.
Well, this is exactly the same thing with customers, right? We always say, hey, we should do Agile because, you know, until the customer sees something, they don't actually know what they want.
Exactly.
Same thing for programmers, right? Until we start to see what we're doing, we don't actually
You don't always know that it is actually what you want. But hopefully once you see it, at that point you're in a position to say, yes, that is actually what I wanted, or no, that is not what I actually wanted. Too much time. Who said that one? That was you? Okay. Now can you see that it's much less time to actually write your tests? About the same. So you're used to figuring out exactly what the piece is. We hear that actually a lot. Copy and paste. Yes. And it's exactly the same philosophy. All we were doing was taking the philosophy that we were using.
making some helpers.
Made some helpers, yeah.
Yep.
Legacy code. Okay, we didn't talk about legacy code too much in this particular talk, but notice that all the tests we actually did here were against legacy code. We didn't actually write any of the implementations, and that is a really kind of nice thing. And with legacy code, there's a particularly nice thing about it, right?
What's that? It runs?
It runs. Well, so the first part, right, is you do the do, and you produce some object, right? And say, now when you're creating some code, you have to look at that object, and you have to say, is this what I expect? But with legacy code, we'll just do the demonstration. I run some legacy code, it produces this. Is this correct? Yes. Why is it correct?
That's what it's doing.
Exactly. So with legacy code, and we've done locks, we've gone into projects where there's zero coverage and gotten it up to 80 to 90% in about 35 minutes. And the reason is we'll just spit out what it does. We'll take a database, throw whatever's in there against it, see what comes out, and then lock it. And we don't care. You know, we've generated 8 meg log files. Is that correct? Of course it's correct. That's what it produces. Then I can start going in and seeing, can I change stuff without changing it? So locking legacy code, extremely powerful way to do it, because you no longer have to worry about what it produced. You just have to be able to run it. Now, if your legacy code doesn't run, that's another issue.
Yeah.
That's another issue.
That's a couple of long nights, and maybe you get a new job.
Maintaining tests. I think that came from the back. All right, maintaining tests is another thing that's really nice about approvals. When your code changes, you don't, so if 5 things change, you don't have to go and figure out what the 5 things were. And you just literally have to look at it, and hit the button that says approved. And so maintenance really drops a lot.
Yeah, so one other thing we've heard, right, is you want that granularity of testing little pieces, right? And one thing that we found out is once you start describing your object as a whole, that starts to narrow
widen.
down. And yeah, so then you basically don't have that many tests, and you're not constantly updating, you know.
And you see this anyways when you look at that shift towards BDD. You started writing tests a lot more about the behavior that you wanted, and that meant less tests about the implementation. Because as long as your behavior was okay, your ability to write to behavior just becomes enhanced. You don't know how. Lady in the red dress, right? Or red shirt, sorry. Do you know how to now? Woo!
Yeah. You also have a community.
And then this other aspect, simple with manual tests only. This idea that creating the manual test is just as simple, or is really simple, so why do I need that automated test? And here, if you have the manual test, it literally is the same line every time, approve, and that will give you the granularity that you want.
And manual
or the
test
regression.
makes regression testing really, really hard.
Yeah. We were using Rspec, but it works with both. First of all,
no, it doesn't.
What?
It doesn't work with Cucumber yet.
Oh, does it?
Unless you coded it, I didn't.
It will work by Cucumber probably by the end of Hackathon. Sorry, what?
What's this thing called, and where do I get it?
Approvals.
So they're actually on your...
Yeah, on that little sheet underneath the survey, there's a list of sort of resources. You can grab it from GitHub. It's open source.
It's called approvals.
It's called approvals.
Yeah. So the Ruby libraries in GitHub,
Yeah.
the Java, C# are in SourceForge.
SourceForge, depending on which language you happen to be in. We highly encourage you, if you're working in some other language, just program it up. It's very simple to do. The philosophy is always the same. Look at what you got, store it to a file. If it matches, you're good.
Okay.
All right, let's talk a little bit about promising places.
HTML.
HTML, you saw there, you have this ability now both to see the code and to see how it actually renders in the browser. And you can approve against different browsers too, which is really nice. Say this, you can look at the HTML, look at it in, or render it for Firefox and make your approval against there. Render it in IE, make your approval there. Render it in the
Safari.
Google's thing?
Chrome.
Chrome, there we go. Which is really nice because browsers are an issue. What?
What if you're testing something like a JavaScript complete tag with an API?
Tell them about JavaScript.
All right, so
Well,
yeah, JavaScript, right.
Something that's dynamic, it's not visual.
So,
Indeterministic calls.
wait. Dynamic or just not visual? Okay, so the arrays that we started with are not visual, right? And the objects that we're starting, most of the time, a lot of what you test is not visual. So one of the things that you'll find you start doing with approvals is you start writing a lot of toStrings on your objects so that you can actually look at them and see if they are in the state that you want.
But I
This
like
has-
the type.
What?
I like getting just the type of the name of the class.
Yeah. Yeah, that's one of the more annoying things, that when you do an approval and you get back just the type of the object. Right? It tells you absolutely nothing about what you got. So the first thing you'll do is you'll start writing that toString so you can see it. It has a side effect that's very nice, which is when you're debugging your code, right? So when you debug code, basically what happens is you think your code is going like this, but it turns out it's not. Somewhere around there it jumps the track, right? And so when you debug, you're trying to figure out where does my code not match up on this path. And a lot of times you're in your debugger and you're looking down through the path and trying to get an idea into this vision of what's going on with your code. If you've taken the time to write toStrings so that you can nicely see your code, it's very easy then just to step through and be like, oh, that's where it jumped the path. Because you've put that time ahead of time into saying, how can I easily see what's going on in my code?
Yeah, it's like the bowling example, right? If you were to actually write a nice descriptive output for the scorecard, you could actually see, every frame instead of testing frame 0, 1, 2, 3, 4, 5. You could actually get the whole thing, which then in turn, when you're pair programming, makes it easier to communicate between each other. So,
But the other aspect of JavaScript is that you have to use, what was your library?
Well, JSpec's being made, right? But there's a bunch of them.
Because the approval has to actually, to approve the JavaScript, since you no longer have access to the file system, has to actually make a web call back to say, this is what I've gotten. But it is very doable. And
so we're going to do
do
some cross-site scripting.
Yeah. So HTML. GUIs, extremely useful. When you approve a GUI, it literally you just hand it the object, and it does a screenshot. And so you look at a picture of what the GUI looks like. They're one of the easiest things out there to test. Databases and web service. There's two aspects to this. One is you can take back a query result, spit it out as a CVS file, and it's very easy to actually see what's going on. The other, and there's a whole bunch of this on the blog, on the page, you can attack an indeterministic thing like a database, right, with an approval. Okay. With an approval in this way. So let's say I want to query a database, right? So I create an object that just holds onto these two things. Basically, you need the query, and then you need to execute the query. So when you test this object, right, it's going to produce that query. And the first time, the query is not going to match anything because there's nothing on the pedestal. So it's going to go and it's going to fail. And it's going to say, so let's say the first time you write the query, you have select star from person. Right? So it's going to go to your database, execute this query, and give you back a result set, all the people in your database. You're going to look at it and you're going to say, oh yeah, that's really what I want. And then you're going to approve it. But what gets approved is only the query. So you get that instant feedback the first time. But when you run this again, it's going to come up and it's going to say select star from person. And it's going to match what you did before. So it won't even go to the database. It doesn't matter if you even have a database. At that point, it's just going to continue to pass. So you get that nice regression. You're asking the database the same thing. Sometime in the future, something's going to change. So let's say it changes and now it says, well, the same thing, but where status equals false.
Alive.
Or alive. Yeah, that's probably better. Now, it's going to fail, right? Because this query doesn't match this query. It's going to take both queries and execute them against your current database. And it will show you a report. This is the query you used to have, and these are the results it will currently give you. And this is the query you now have, and these are the results it will currently give you, which gives you that nice granularity, even though between the time you started and the time you've ended, your database, of course, has changed quite a lot. So A, you have this ability now to test with feedback, regression, and specification against an indeterministic situation. Of course, databases aren't actually indeterministic. You can constrain yourself and get yourself into a database. It's just a lot of work, which brings us to the second point. Right? This works really great even if you can't. Say you're testing a web API out there, right? So something that gives you the weather, right? You don't own the API, so there's no way to actually confine it. So the best you could do is just mock it out. Here you can actually test it. In the database, you can actually confine it, but it's just a lot of work. Now you don't need to, especially if it's just a query. Point it at your production database. You're fine. Yeah. Multiple asserts. Anytime you have a test that has multiple asserts in there, it's crying out to be replaced with an approval.
XML, we showed that one. Arrays and lists. And helping with debugging. So once you've started describing your objects more for your approvals, when you have to debug, you can actually get this information quickly without having to set like 15 things in the watch window.
Yes. And then we talked about it a little bit, but locking a piece of legacy code is extremely easy. ApprovalTest.com has sort of links to everything. And of course, it's on GitHub, which is where you'll actually download the gem.
Yep. Well, I'm Dan Gilkerson.
And I'm Llewellyn Falco. And we approve this talk. Before we do questions, there are surveys in front of you. If you honestly answer them, you'll get better talks in the future. Should we take questions?
Oh, yeah.
Or actually, yeah, we probably have to. Yeah. Sorry.
Is the idea of approval tests original to you, or where did it come from?
The philosophy is a golden master test. And the idea is definitely not original to us. And you hear from the back, people who test, there's a saying that test the code and the code test the test. This idea of seeing what you want and copying it, that's been around much longer than us. But the actual implementation of a tool to sort of do it for you, that's original to us.
Right. And we're not set on just our tools, right? This library is just applying this concept, helping us out. So
yeah,
more feedback, more changes.
Could you just talk about real quickly how you'd actually install that into, like, the approval stuff into, like, a Rails or Ruby project? I guess when I looked on GitHub, it wasn't 100% clear.
No. Yeah, the
does it just go into the lib directory or?
Yeah. So the gem is being built. I can't get this back in.
Open it up. I'll put it in. Yeah, so it is a gem. When I installed, because I have the source, I just do a rake build install. But I think you can just download the gem straight by clicking on the little gem icon.
Yeah. So you gem install, it's approval_tests when it gets on Ruby Forge. But right now it's approvals-approval_tests when it's built. But what I'll show you is all you need when you actually set this up is to require approval tests, and then, just to make it easier, we include approval tests.
And there's no configuration either. It uses the information in the spec to figure out what the name of the file should be and where the location of the file should be.
Right. So right now these are really tied.
Yeah.
These are actually really tightly coupled to our spec right now. So pulling the describe and the it labels is all we have right now. All right.
Do you run into a lot of things like if you make one little change in a layout that you have to approve 40 or 50 different files?
Not usually, but there's a couple things that are dependent on that. The first is, a lot of times people think, okay, we just showed how you can see the whole HTML file, and that's really nice. But a lot of times you don't actually want to do that, because again, a lot of times the full HTML has sort of a title bar, and it has sort of the part that you're looking at and a sidebar. And so a lot of times we actually just approve either, the title bar, the sidebars. We don't do the entire thing, which prevents sort of what you're saying of sort of the title bar change.
How do you break that apart, though?
What?
How do you break that apart?
In our code, we have a part that renders the title bar, and we call render the title bar. Right. The second part is, and because it's still passing you back HTML, it's really valid. The second part is sort of, there's this idea of sort of like CSS, right, styles. But keep in mind that the CSS is dynamically linked. So the CSS changes actually don't get detected. They won't cause a failing approval, right? And that turns out to be rather nice because
yeah, just
really
I could picture like putting in, I don't know, maybe a new JavaScript library and having to approve a ton of files.
And that wouldn't happen either, because unless you actually pulled out the library in each one, if you link your JavaScript, it doesn't affect it at all, because the artifact doesn't actually.
So it doesn't catch script tags or things like that?
It catches script tags, but if you have a library, you're actually linking to the file. Right? If you pull the library out, then you'll get that issue. And then you get a separate issue, too, that sometimes you'll do something like you'll change like a core thing that's everywhere. Right? And what happens in that situation is you get a whole bunch of failing tests. Say you get like 40 failing tests. Right? This is actually very rare. But when it does occur, what happens is you just sort of glance at the 40 files, because you're looking for one thing in particular. Check that they're all still cool, and then I'll just batch approve all of them.
Yeah, I mean, obviously, there's a lot of room for new tools here to help us approve faster, get the chunks that we want. So, you know, when we're used to writing the shoulds and getting the little block of code, well, that little block of code that we're trying to, you know, assert on, we can just approve on and focus more time on actually getting the chunks of code we want, or the results that we want, and not actually trying to verify that result. So,
Yeah.
small is fine.
Anything else? All right. Thanks very much.
Thank you.